We can think of multiplication as repeated addition, and we have area models that will help us see that repeated addition. If we're multiplying 2 times 3, we can think of that as 2 rows of 3 blocks, which gives us a total of 6 blocks. So the product of 2 and 3 is 6. When we take that process in reverse, in other words, we start with the 6, and then we want to know what do we multiply to get 6, we're doing what's called factoring. And in this case, what we know is that the area is 6, and we'd like to know the dimensions of this rectangle that will give us an area of 6. Well, obviously, we already know that 2 times 3 is 6. So one way to factor 6 is 2 times 3. But there is another way to factor 6. We could say that 6 is the same thing as 1 times 6. So when it comes to factoring, there is sometimes more than one way to factor an expression. Now, since 6 is 2 times 3, and it's also 1 times 6, we can say that the factors of 6 are 1, 2, 3, and 6. We can do that with any number. If we wanted to know what the factors of 15 are, we could think of 15 as 1 times 15, or 3 times 5. So the factors of 15 are 1, 3, 5, and 15. By comparing the numbers in the lists, we can see that there are some factors that happen in both lists. Those are called common factors. And if we're asked to find the greatest common factor, that's the largest factor that is a factor of both 6 and 15, which in this case is the 3. We're going to use these ideas that we've just seen with numbers, the ideas of factors, common factors, and greatest common factors, in order to factor expressions that have variables in them. Now, really, it's not that difficult. Just hang in there, you'll see. So let's start with an expression that has a variable in it, and in this case we want to multiply. We know that to multiply 4 times the quantity x plus 2, we'll be using the distributive property. And we also know that we can draw an area model to represent that multiplication. So we're finding the area of the rectangle that measures 4 units by x units, that's 4x, and the area of the part of the rectangle that measures 4 units by 2 units, 4 times 2, that's 8. So the total area of the rectangle is 4x plus 8. Now what if we start with the 4x plus 8 and we're asked to factor it? What does that really mean? Well, it means that we want to find two expressions that we multiply together to give us 4x plus 8. And in terms of our area model, it means that 4x plus 8 is the area, and we want to find the length and the width that we would multiply to give us the area of 4x plus 8. Just like with numbers, there may be more than one combination of dimensions that will give us an area of 4x plus 8. So let's see if we can draw some pictures and see those possible dimensions. This is maybe the most trivial one. 1 times 4x plus 8 gives us 4x plus 8. But we can take those same areas and rearrange them and find some other combinations of dimensions, like this one, 2 times 2x plus 4. That also is an area of 4x plus 8. And we can arrange again to find another combination of dimensions that give us the same area. In this case, 4 times x plus 2. Now, all three of those expressions we just found, 1 times 4x plus 8, 2 times 2x plus 4, and 4 times x plus 2, all will give us 4x plus 8. So if we're asked to factor, which one do we want to consider the right answer? Well, chances are you'll be asked to factor out a greatest common factor. And in this case, that last expression, 4 times the quantity x plus 2, would be considered completely factored. And that's because 4 is the greatest common factor of both 4x and 8. So taking an expression like 4x plus 8 and writing it as 4 times the quantity x plus 2 is just factoring out the greatest common factor. Make sense? Okay, then let's try one more. And we're going to use an area model for this one as well to help us understand what's going on visually in the problem. Let's factor 6x squared minus 15x. If we use an area model, we can think of the total area as being 6x squared minus 15x, but we'll subdivide that into two smaller areas. Now we need to find the length and the width of the rectangle, and the length will be the greatest common factor of 6x squared and negative 15x. Well, let's break that down a little bit, and first find the greatest common factor of 6 and negative 15. That's the same as the greatest common factor of 6 and 15, which we already found to be 3. Then we'll find the greatest common factor of x squared and x. That's the most number of factors of x that those two expressions have in common, which is just a single x. So 3x is the greatest common factor of 6x squared and negative 15x. Now let's look at the two smaller rectangles that make up our area model. First, the one that has an area of 6x squared. To get that area, we'd have to say 3x times something is 6x squared. That would have to be 2x. And then if we look at the area of the blue rectangle, which is negative 15x, we'd have to say 3x times something is negative 15x. That's negative 5. So when we factor 6x squared minus 15x, we can factor that into 3x times the quantity 2x minus 5. Yeah, that's not so bad, is it? When you look at it as an area and you think about lengths and widths, factoring out a greatest common factor is really not that difficult.